Hello everyone. In this video, I will first explain the committee formation problem. I will explain clearly about what is the input representation and what is the out- output expected and how to interact with the constraints. And this cannot understand in the greedy approach and we discuss about the problem. And the problem given is each group represents the students belonging to various groups, villages and farms. After that, they will give the case size of committee size. After that, we are also given the integer k, which represents the size of each committee. Each committee must exactly constrains k size. After that, no two students in the committee come from this same group. A student cannot be reused in the multiple committees. After that, the input formation is the input format is the first one consists of n and k. This is the number of test cases and 5 is the number of size and k is the size of committee. And n is the number of students or group numbers that consists of values. Mm, After that, the output format. For each input, the integer represents the maximum number of committees that can be formed while satisfying the given constraints. The constraints are k from 2 to 20 range and n from k means the k from 2 to range 2 to 20 and below 50. That is the size of n or the limit of n and that is the limit of k. After that, a of I is an integer type because it is up to 10 power 9. And the number of group is small. That means the number of students from each group is very large. Even if the total number of students is very large, we may not able to form the many committees. So we will approach the two major brute forces, and this is the algo or code which is given below. And we'll see each iteration how the greedy approaches will solve this question. And we will explain why not this not solve all each test cases. For example, let's list down here what are the approaches we are given. Brute force. We will decide after the time complexity and the space complexity after the explanation of the each algo. Let's take an example. Number of groups 5. In input we can consider as this is n and the committee size is 3. In input we can consider this as k and the array is given as length 5. So you can take 4, 2, 2, 1, 1. And we will see how in each iteration this solves. Iteration 1 in the given array 4, 2, 2, 1, 1. Taken batch and the number of committees. So I can as greedy we take from as committee size 3, we first take this 3. 4 minus 1, 3, 1, 1, 1, 1. The committee form is 1. And on second iteration, let's list down this list here and we take these 3. 20011. Number of committees up to now is 3. On iteration 3, 20011. As this G2 and G3 are 0, we not consider for further. And let's consider G1, G3 and G4. 10000 and 3. G1, G2, G3, G4, G5 on given 42211. On first iteration, we got 3, 1, 1, 1, 1. As we consider these three. On iteration 2, we consider these three. 20011. And G2 and G3 are zeros we do not consider further. On iteration 3, we consider G1, G4, G5. 10000. And we got three committees. And we left our one member on G1 as the given constraints, the committee size is as the committee size is 3 and the committee size is 3 as we left over one we do not consider this member. And I think you have understood why the grid approach is not formed. All the students are still available, they are not considered in any another group. The greedy approach exhausted medium-sized groups only. The time complexity, this will take n and this will take k. N into k. N into k and in big O of n. The space complexity is 1. And greedy approach second approach is greedy. It's my mistake. Greedy approach. And it is all go for greedy approach. Not greedy approach, it is sorting approach. Sorting approach. This is a sorting approach as we see. At first we have sorting the given array. And for that, we first sort the groups based on the given number of students. And each step we pick one student from the top case group and reduce their count. For example, the n given is 5 is the size of array and k is given 2. It is the committee size and the array values are 5, 3, 2, 2, 1. Okay, let's sort these values as given array is also already sorted. 5, 3, 2, 2, 1. On first iteration, as greedy approach, same. On the number of committees forms. On first iteration, 5, 3, 2, 2, 1. And we take first three values, this 5, 3, 2. And on first iteration, we reduce by 1. No. As k is 2. 4, 2, 2, 2, 1. And we form one committee. On second iteration, 4, 2, 2, 2, 1. We take from this 3, 1, 2, 2, 1 and form two committees. And at last we go here, we form 6 committees at last and we left one another member. After each iteration, the group size changes and make the previous sorted. And the time complexity for this as sorting we got big O of n log n as we perform cycle sort, binder sort, or any other thing, plus repeated iterations. We need n here on k by sum, and we need n. So it is almost big O of n square, which is not perfect to practice a good coder. And the time complexity and the space complexity is big O of n. As we are sorting the array and storing the size value and sum value and used values. And at last, my teammate will explain the binary approach, which can be solved in big O of n log n, but space conflict big O of n. As we consider these two, big O of n log n is very best approach to solve this problem.
Hi, I am Sai Sharvani Belvada. The optimal approach for committee formation question is binary search and answer. Let's see how it can be possible. Here they gave us the number k, which represents the size of committee, and they gave us an array which contains the number of students in the ith group. And they asked us the maximum number of committees that can be formed. They also specified that no two students from the same group can be in the same committee. So we can determine that the least value that can be formed is 0. Let me explain with an example. See here, I took an array which contains two groups and the size of the committee is 3. See here, we have to retrieve 3 people from 3 different groups to form a committee. But here, we have only 2 groups. So the least value that can be formed on the row value is 0. And let's determine the height. Here, the total by k equal to at most number of committees that can be formed. See, here total is 21 and the size is 4, which forms at most 5 number of committees. See, because let's see why. Here we have x equal to 6 and the array size is 6. 6 into 6 equal to 36. So 36 students form a committee of x equal to 6. But here the total number of students is 21. So we can say that at most 5 number of committees that can be formed. That is total by k. Let's apply binary search on low and high using low and high. Sorry. Here we can find mid using low plus high minus low by 2 or low plus high by 2. And we apply this formula for L and R. We will find x equal to 2 first, which means we have to check the feasibility whether we can form those many number of committees. Here k into x represents needed. That means these number of students that are required for forming that community. And this have represents those many number of students that we have. See if, let's see this later. If x equal to 2, that means, and the size equal to k equal to 4. See here we can, if we take the group 1, we have only one member. So we can take only one member from that group, which can be pushed into any one of the committee. And if we take the group 2, which contains two members, we push each member into the two groups, like one for the one committee and another for the another committee. So 2 members. And for the group 3, we see that here 3 members are there. See here 3 members are there, but we have only 2 committees. So we can take only 2 members and we leave one person back. So 2 members only we can take. And as like 3 we will take only 2 members, and for 5 we will take only 2 members, and for 6 we will take only 2 members. which will form 11. That means these number of students that we have. But the total number of students that are needed are k into x. That means 4 into 2, 8 students. As we have more than the required, so it is the feasible solution. See here, if we have more than the required, it is feasible, and we move right to find the maximum, which can be possible later. See here, if the students which are required is greater than the number of students that we have, then the condition get failed, because any value that can be greater than x will need even more students, so these are impossible. So because it cannot form the committee that we want to achieve, so we will move right. See, so now mid low equal to mid plus 1, and we will again find the mid for x equal to 4. So these are the committees that we can form, but we have to find the maximum that we can find through using this bind search. See, for x equal to 4, we can have these many number of students, 80 students, but the required number of students is 16. So it is also the feasible solution. So we can move right to find the much better number of committees that can be formed. So we can find the maximum number of committees. Now we will move right, like low equal to mid plus 1, which means 5, and r equal to 5 means the highest range, and we will find mid, that is 5. So here we will again do the same thing. The number of students that we have is 20, and the required number of students are 20. So it is feasible. So we will again try to find the much better one. But as we move forward, low equal to mid plus 1, it is 6, which means it is greater than the number that we have to want. Means it crosses the left greater than right. So the maximum number of committees that we can achieve is 5. We can form is 5. Let's see the time complexity. N is the number of groups, and binary search runs in log of total by k. And for each mid value in the binary search, we iterate over entire array once, so it is n. And the overall time complexity is n log total by k. We did not take any extra space. We used only variables. So of 1, it is constant space. Thank you.